Hello friends, welcome back to my YouTube channel. So in last video we have solved a problem of continuous beam. How to analyze the continuous beam by using Kani's method. We have solved two problems on continuous beam. Today we will see a problem of portal frame. How to analyze this by using the Kani's method. So we will see. So this is the given problem. So now we will see how to find out the fixed end moment. So here span BC is carrying the point load as well as UDL. So how to calculate the fixed end moment when they have given point load as well as UDL at the same span? We'll see how to solve this. Here span AB as well as span DC is carrying the no load. So here the fixed end moment becomes 0. So that MFAB and MFBA, MFDC and MFCD is equal to 0 because no load is acting on this member. So BC is carrying the point load as well as UDL. For that span BC is carrying the point load. For that we have the formula minus WL divided by 8, and it is also carrying the UDL. For that we have the formula minus WL square divided by L. So I have taken minus common and substitute all the value. It will come out as minus 33.33 kilonewton into meter. Similarly, MFCB is equal to WL divided by 8 plus and WL square divided by 12. So we need to add both because it is carrying the point load as well as UDL. We need to add both the fixed end moment formula. So substitute all the value. It will come out as 33.33 kilonewton into meter. So our next step is to find out the rotation factor. For that we have this. We need to draw this table. It is carrying the joints. Here we have two joints B and C. For joint B it has the member BA and BC. Joint C it has the member CB and CD. So I have written here. So now we'll calculate the stiffness for member BA. So for member BA it is the far end is fixed in. If far end is fixed, we have the formula. So we have the formula I divided by L. So by using this formula we'll calculate the stiffness for member BA. So high value given is 2I and length is 4 meter. High is 2I, length is 4 meter. It will come out as 0.5I. Similarly, BC for member BC far end is continuing. If far end is continuing, we have the formula again same I divided by L. So here I is 2I and length is 5 meter. So put this value I is 2I, length is 5 meter. It will come out as 0.4I. Similarly for CB it is continuing. For end is, if it is continuing, we have the formula I divided by L. So I given is I is 2I and length is 5. So it is come out as same as this 0.4I. Similarly for CD it is fixed and we have the I divided by L. Again same formula is I is 2I and length is 4 meter. So we need to substitute I is 2I, length is 4 meter. It will come out as 0.5I. So now we will do the summation of K. 0.5I plus 0.4I. It will come out as 0.9I. So for this also 0.9I. So now for rotation factor we have the formula one third of distribution factor. The distribution factor formula is K divided by summation of K. So K is 0.5, summation of K is 0.9. So 0.5I divided by 0.9I. It will come out as minus 0.27. Similarly for BC, rotation factor is equal to minus of into 0.4I divided by 0.9I. It will come out as minus 0.22. So for this also it will come out as minus 0.22. And rotation factor for this it will come out as minus 0.27. So this is how we have to calculate the rotation factor. The step is to rotation moment, to find out the rotation moment. So we need to draw the diagram like this. So wherever joint is there, we need to draw this kind of boxes. So first thing what we have to do is write down the here fixed end moments what we have calculated. end moment of AB is 0 and fixed end moment of BA is 0. Write it here. Fixed end moment of BC we got was minus 33.33. Fixed end moment of CB we got was 33.33 and fixed end moment of CD we got was 0 and for DC we got was 0. So now what second step what we have to do is add these two and write it here in this box. Add these two, write it in this box. So 0 plus minus 33.33, it will come out as minus 33.33 and here also it will come out as 33.33. So here write on the rotation factor of BA and rotation factor of BA we got was minus 0.27. Rotation factor of BC we got was minus 0.22 minus 0.22. Here also we got was minus 0.22. Here rotation factor of CD we got was minus 0.27. Minus 0.27. So now what we have to do is, so this into this plus foreign moment, this plus this, it will come out as 8.99. Again this into this plus this and this add, so it will come out as 7.33. and for CB this into this plus and foreign moment of this one, it will come out as minus 8.94. and for CD this into this plus this, so it will come out as minus 10.97. So for second iteration, this into this plus this one, foreign moment of this one, so it will come out as minus 11.41. again this into this plus this, so it will come out as 9.29. so again for CB this into this plus this one, so it will come out as minus 9.37. again for CD this into this plus this one, it will come out as minus 11.50. so again for third iteration, this into this plus this one, it will come out as 11.52. again for BC this into this plus this one, so it will come out as 9.39. it will come out as 9.39. again for CB this into this plus this, it will come out as minus 9.39. for CD this into this plus this one, so it will come out as minus 11.53. so we'll do one more iteration. For this into this one plus this one, it will come out as 11.53. again for BC this into this plus this one, it will come out as 9.39. again for CB this into this plus this one, it will come out as minus 9.39. again for CD this into this plus this one, it will come out as minus 11.53. here almost we got the similar answer. Now we have to stop here. So these are our final rotation moment value. So now we will go for the step number 4, find outing the final moment. For that we have the formula MAB is equal to MFAB plus 2 into near end rotation moment plus far end rotation moment. So here I have split all the this formula into here. MFAB is nothing but our fixed end moment, so I have already written all the fixed end moment, and here AB 1 2 is nothing but the members, corresponding members I have written here. 2 into rotation moment of 1 2 is nothing but rotation moment of this corresponding members, and here rotation moment of 2 1, and rotation moment here M12 is nothing but our final moment. So now we'll see one by one. Fixed end moment of AB is 0 and 2 into M dash of 1 is nothing but rotation factor of AB. Rotation factor of AB, there is no rotation factor for AB. So keep it as 0, and rotation factor of 2 1 is nothing but rotation factor of BA. Rotation factor of BA we got was 11.53. So substitute that 11.53. Now add these 3, it will come out as 11.53. Similarly for BA, fixed end moment is 0. 2 into rotation factor of BA we got was 11.53. 2 into 11.53 rotation factor of AB. There is no rotation factor for AB. Keep it as 0. Now add these 3. It will come out as 23.06. Similarly for BC, this is a fixed end moment. So 2 into rotation factor of BC we got was 9.39. So put that value 9.39. Rotation factor of CB we got was minus 9.31, minus 9.39, sorry, minus 9.39. Now add these 3, it will come out as minus 23.94. Similarly for CB, this is the fixed end moment, and 2 into rotation factor of CB we got was minus 9.39. So put that value minus 9.39. So rotation factor of 2 1 is nothing but rotation factor of BC we got was 9.39. So 9.39. So it will come out as 23.94. Similarly for CD, so 2 into rotation factor of CD we got was minus 11.53. So 2 into minus 11.53 into rotation factor of DC. There is no rotation factor for DC. Keep it as 0. Now add these 3. It will come out as minus 23.06. Similarly for DC, 2 into rotation factor of 1 2 is nothing. Rotation factor of DC, there is no rotation factor. Keep it as 0. And M plus 2 1 is nothing but rotation factor of CD we got was minus 11.53. So minus 11.53. Now add these 3. It will come out as minus 11.53. So these are our final moments of corresponding members. Now using these final moments, we'll draw the net bending moment diagram. So this is our given problem. So span BC is having the UDL. For that we have the pre-body diagram parabola. To find out this maximum height, we have this formula. So substitute all the value, it will come out as 31.25, the maximum height of this parabola, and the maximum height of this point load will be 25. So by using this formula we got 25. So this is our pre-body diagram of this problem. Now we will see the net bending moment diagram. So by using these final moments, so our AB value we got was 11.53. So first point is A. So at point A, so 11.53 means it is positive. At point A, positive value comes here, because here sign convention here, minus plus plus minus. So plus value means it comes here below the neutral axis, it comes here 11.53. So for similarly for BA, first point is B. At point B it is 23.06. At point P 23.06. At point P positive value comes above the neutral axis, it means it comes here 23.06, it comes here. Similarly for BC, here first point is B. At point P minus 23.94. At point B, so minus 23.94. So minus means it comes above the neutral axis, it comes here minus 23.94, it comes here. And similarly for CB, or first point is C. At point C value is 23.94. so it is positive means it comes above the neutral axis, it comes here 23.94, it comes here. Similarly for CD, or first point is C. At point C the value is minus 23.06. so at point C minus, so plus minus minus plus, so negative value comes here, so it means it comes here 23.06. And at point for member DC, here first point is D. At point D the value is minus 11.53, minus 11.53. At point D negative value comes here, so it comes here 11.53. so now join all the lines. See here, this is our net pending movement diagram. So here our problem ends. If you like the video, like it, share it and subscribe for the more videos. Thank you for watching.